So good afternoon. Our team name is VIVA, and our project title is Wireless Bluetooth Hub. My name is Addis Elliott. I'm a senior computer engineering student.
My name is Jordan Coles. I'm a senior computer engineering student.
My name is Kadeem Jones. I'm a senior electrical engineering student.
My name is Christian Ford. I'm a senior electrical engineering student.
Next slide.
So our motivation, we are here to develop a solution that would solve the problem of a noisy ruckus of a sports bar. We want to allow all the patrons that are attending these sports bars to be able to have the luxury to enjoy the entertainment of their choice. We also want to develop and implement a design that exhibits the Bluetooth technology to resolve these issues, that will allow them to come to these sports bars without disrupting the atmosphere of enjoying the entertainment of their choice, is also viewing and being able to socialize in the process.
Next slide.
So for the overview of this project, I went over a little bit of the background. We're going to go a little deeper, and also to talk about the problem analysis. Go over a quick overview of our demo as well, our requirement specifications, and then follow up with our proposed design for the project.
So our background and problem analysis. So in our introduction, as Jordan first talked about, she gave you guys our need, our motivation behind this project. I'm going to talk about more of our objective statement, or what we plan to do as a proposed solution. So our solution is to create a completely wireless and efficient system that will allow for audio from at least two separate sources to be broadcasted to wirelessly into a confined area simultaneously. Once we implement a circuit board that would serve as a wireless Bluetooth system between the mobile music device and a multitude of listening devices. This system should allow a user to select an audio channel of his or her choice to play through his or her personal listening device. Bluetooth would be used to connect both of this interaction between the source of the music and the listening device. The overall goal would be to design a system that will allow 10 people to listen to each of these audio streams simultaneously in this way. So some of the relevant papers and relevant information or background regarding our project. The first paper is a practical approach to quality of service in Bluetooth PicoNet. So this paper serves to explore the bounds of a Bluetooth PicoNet. In its attempt, the focus is to expand support not only to IP, but non-IP protocol services, as well as scalability without affecting the current arrangement of slaves. It directly relates to concerns that we are having with our idea, and that we are trying to stretch the limits of the PicoNet to fit our project goals. The second relevant paper is Bluetooth PicoNet applications. This paper serves to further understand the applications of the PicoNet as it relates to the data transfer among Bluetooth-enabled devices. This will allow us to be pre-exposed to the challenges that we may face regarding Bluetooth interference with wireless local area networks. It also gives us a preface to the problem we are trying to solve of creating a completely wireless, inexpensive audio system with ease of connectivity through Bluetooth. Our third paper that is relevant to our project is ScatterNet Part 1, Baseband versus Host Stack Implementation. This paper serves to give an introduction to ScatterNets and the possible implementations of them. It gives us the opportunity to understand how our project bounds may be extended and better designed with possible implementation of the ScatterNet. It also gives us a chance to understand the possible risk associated with trying to implement ScatterNets and how to approach the best application practices. A patent that is relevant to our project is the surround sound effects provided by cell phones. This patent serves to better understand how wireless communication devices may have an effect on one another as it relates to sound transmission. As we aim to transmit sound across multiple devices within a single environment, it is important to understand what to take into consideration during or even before implementation. A relevant product that we have found was the Ultimate Ears, or UE Boom speaker system. This wireless Bluetooth speaker system allows the transmission of audio across multiple Bluetooth speakers. It is more specifically an extension of an original point-to-point connection of a mobile music device to a singular UE Boom speaker. The second speaker is then connected to the original speaker through Bluetooth to create a wireless system that extends across the two speakers. It is the only system on the market today that we have found that is directly related to extending an audio signal over a Bluetooth network to multiple audio listening devices. Some of the parts that we have found in the senior design lab that relate directly to our project, the Intel Atom board. This also helps us to intertwine with the TI Texas Instruments competition. So the competition uses Intel Atom board in your design. So we were trying to figure out how we could implement the Intel Atom board within our project. And so this represents a circuit board with extensive microprocessor capabilities that could possibly be programmed to create a solution to our issue. This product was created by Intel to have functionality that can be tested by student projects and can be used to possibly enter the Intel Cornell Cup competition. So this competition is actually the Intel Cornell Cup competition. The TI Stellaris Simplicity Kit. This kit provides a low power RF solution for customers and equipment. The solution combines TI's easy-to-use simplicity protocol with Stellaris EM2 expansion board and evaluation module with the full suite of tools and engineering needs to develop a prototype. This kit would give us the opportunity to test the capabilities as far as Bluetooth is concerned and demo its functionality as it relates to our project. Next slide. We're going to go over the demo after our actual presentation, but our demo is, in this demo we'll attempt to give a preface to our design by implementing a circuit that allows for the transfer of audio data across into a speaker. So, next slide.
Okay, so we have some requirement specifications that I would like to go over. So first, we created some engineering requirements. So the first engineering requirement is the application must be intuitive and allow for user of application to fully understand capabilities within 5 minutes. So to ensure of this, we can just simply use the stopwatch to monitor and test a random subject while they attempt to understand the application. Secondly, the application and hardware system must have a setup time for 7 devices in less than 10 minutes. Simply again, we would use a stopwatch to monitor how long it takes to fully set up the system. Thirdly, the board must be compatible with at least 2 different Bluetooth speakers, brand or types. So we're going to set up a system using the 2 Bluetooth brands and see how they intertwine with each other. The system must be operable with at least 2 mobile devices configured in the network, either Apple or Android. We'll set up the system using these devices and see if they're compatible. Fourthly, the total hardware system must be able to fit in a briefcase or laptop bag with a dimension less than 16 by 16. So we use a tape measure to measure the total dimensions of the project.
So, excuse me, the last marketing requirement was the system must produce quality audio. The way in which we broke that down into our engineering requirements was to say that each speaker in the wireless connection must not experience a sound distortion less than 15 feet radius from the hub that is receiving the signal. The way in which we would test this is actually listening to the sound outside that 15-foot radius. The last engineering requirement for this same marketing requirement is that the system itself must have a low noise so that it won't distort the actual audio trying to be played. The way in which we specify this requirement is by saying that the device, when not playing any sound, should not be audible louder than 30 decibels, and we would just use a decibel meter to measure this when it's not running.
So what kind of noise would that be? Classify that as?
Like sound outside when the speaker's on.
So I guess I'm saying, is there a technical name for it? Is that background noise or?
Well, any noise that comes from it that is not going to be the audio, like when the device is off and not playing any music, any sound that comes from it. So I guess the technical term may be background noise. Background noise or feedback.
Yeah, there may be something I'm not thinking of right now, but system noise or something like that. But I get what you're saying. I understand what you're saying. All right. So right here where you say the application and hardware system must have setup time for 7 devices in less than 10 minutes. What is that? What do you mean by 7 devices?
So we categorize a device as a speaker and not the actual hardware or the Bluetooth hub. So if we're looking up 7 Bluetooth speakers in the network, then it must take less than that time to implement.
Okay, so how is that device different from the mobile devices that you're referring to? You say the system must be operable with at least 2 mobile devices fitted in the network.
That's saying it must be operable with 2 mobile devices, but this requirement dealt with the setup time using 7 devices. I don't think I understand your question.
Yeah, how are the mobile devices that you refer to in that requirement different from where you say you want to set up 7 devices in less than 10 minutes?
So I see the 7, okay.
And then the other one is for the second one for the market requirement too. The system must be operable with at least 2 mobile devices. The devices configured in the network.
So I must have not adequately explained that, but a mobile device is any device. So the Bluetooth speaker is a mobile device, and the cell phone is a mobile device. But at the same time, when we were talking about the 2 mobile devices there, we were specifically referring to cell phones.
All right. But in the other one, you're talking about the speakers. And the first one, the second one for market requirement.
Well, not just speakers, because 2 cell phones assembled in a circuit will still count as 2 mobile devices.
Okay, so that needs to be made clear. So that's ambiguous, right? At least number 1 is ambiguous. And even number 2 is ambiguous. Because you said the system must be operable with at least, 2 mobile devices configured in the network. So what do you mean by configured in the network? Yeah, what do you mean by that? So, and some of the other ones are probably. So we need to go over those point by point to make sure that they fit all the requirements and that we're clear about what you're saying. All right, y'all ready for the next one?
Yes.
Okay, for the proposed design, this is our level 05 diagram. Just detailing the inputs for this wireless Bluetooth hub will be the wireless audio input, which would be the Bluetooth signal. Also having capability for an audio jack for a wired connection to a speaker, and then the 5-volt power is going into the circuit. For outputs of this hub, that would be the output audio, that would be a Bluetooth signal, and an LED on the hub that will be used for status indicators.
So your system, you're saying your system only consists of the hub itself? By the way, in the future we want to, Bluetooth implies wireless, so you don't have to say wireless when you say Bluetooth. But are you saying that's the only part of your system? Or are you not considering the devices themselves? The mobile devices or the speakers?
The mobile devices themselves count as just peripherals.
Okay.
So the hub itself is what we would be working on. The peripherals would just be attached to either the input, those mobile devices, and then the output of the actual system. So the output would, I guess the output peripheral devices would receive that information from the hub, and then the hub would also receive information from the input peripheral devices.
Okay, so why do you have the audio output? Does that need to be wireless? Is that something that's broadcast in several different places, or audio output?
Yes, it has to reach to the output peripheral devices. So in order for you to get that signal through the devices, that audio signal has to be transferred
Wireless.
wireless.
All right, so, and what's the point of having both wireless audio input and an audio jack? I'm assuming it's input, right?
Yes.
That's input.
Yes, the audio jack, I guess, would allow us to test at different phases. So at the end, instead of removing the audio jack, we'd also have that possibility. It isn't something that someone who would be using the system wouldn't be opposed to. Of course, they can have that Bluetooth connectivity, but just in case that they wanted to have it more stationary, they could put in the audio jack and actually transfer information to the system that way. So it allows for flexibility in using the product.
Okay, and when you need any software to run on the mobile phones themselves,
Yes.
you're gonna have to design software for that, you saying?
Yes. We're gonna have to design
So-
software.
That way, that is part of your system, so you need to account for that somehow. All right, so in that sense, the audio out, for the audio out from the phone, it's just going to be a hardwired connection, right? Plug into the audio jack. So in that case, I think that would be correct, but it would be more than just the hub, it's the actual.
Okay.
I guess you would call it an audio distribution system or something.
Definitely.
All right.
So in conclusion, we just want to go over what we talked about. We talked about our background, which included different relevant papers and information that allowed us to really synthesize the information that we wanted to use for this project. Some of the requirements, specification that allowed us to help detail and understand what it is we have to do in approaching, our proposed goal, and then just kind of highlighting a high-level design, proposed design that will, give us something to look at and, guide us along the way as we complete our project. Now we will do the demo.